Hi everyone, my name is Owen Hodges and I am in the Spring 2016 CIT 360 class, and I wanted to show you guys about uh, runnables, threads today. So I'm going to go ahead and show my code here. As a high level, the code basically is just looking for prime numbers starting at 1 all the way up to 800,000. What I want to talk about first are what each of those topics mean. So first off, a runnable is a piece of code that has what it is to do inside of it. Runnable for this specific application, it is called prime thread, and to make it a runnable, you just need to implement runnable. And as part of being a runnable, it needs to have an override method for the method run. That is what is executed whenever you send this to a thread. So in this instance, it's checking to see if it's a prime, and if it is, it adds it to an array list. And once that's done, it puts it out to a file, and then it closes its thread. So once you get done with running or creating your runnable, now is where you actually get to the chance to send it to a thread. To understand threads, our CPUs nowadays are more than likely multi-core, which inside of those cores they have individual threads as well, which is usually 2 threads to a core. This system I have is a 2-core 2-thread system. So in total, I have 4 threads. So if you look on the main application here, I'm just limiting it to 4 on my thread count. So this will allow each thread on my CPU to of the prime thread, and I can split out the task of calculating from 1 to 800,000 who's a prime number. I do that by taking the start and stop and dividing it by the thread count so that I can get what my increment count is. I then spawn those 4 threads through this method here. Sorry, on top of that, there's an executor service. Instead of managing yourself, which is what I originally did in this application, it's a pain to be able to manage the threads yourself, because you'd have to spawn threads as you need them. You also would have to have a queue for any tasks that come up that need to be handled as well. So that's what the executor service does for you. It creates, in this case, 4 threads that are reusable, as well as a queue. So if I send 10 threads or 10 items to this, it'll start running 4 and put the other 6 in a queue. And as each one gets done, it'll throw a new runnable into each of the different threads that it manages. So in here, I submit those 4 jobs to the executor service. Once that's done, I then combine all of the answers. So I have to sit there and watch it first to see if it is shut down. So I give it the shutdown command so that no more runnables can be sent to it. And then I wait for all of the current threads to finish. Once they're finished, I then move on to doing all the combination of data to the file. So let's go ahead and run this. It's roughly been taking about 26 seconds to run. So in the meantime, while this thing's doing its thing, when I ran this with a single thread, it took forever to finish, just because, again, as it goes up in the numbers, it has a much longer for loop that it has to go through to check to see if it's a prime number, at least in the method I'm using right now. So in this way, I'm able to split out that task and give it to 4 separate cores, and it finishes much quicker. I guess because I'm recording, it was slightly longer. So here's 34 seconds is how long it took. And if we come in here, here's the prime file. So it figures out these are all the primes down to all the way down to 799,999. So that's all the primes between that. Now to show you, I didn't have my task manager up during that time, but I'm going to bring it up this time. I'm going to run it with, let's set it to 2 threads. The CPU for this goes to at most 50%. Going and sort this here. So it's taking a little bit over 50%. That could be for whatever other reason, but it's limited to 2 threads right now. Before this would hit 100% CPU. Now I'm going to go ahead and stop this because I want to show you that, and this is going to take too long for the video. So let's put it back on 4. And this. And then Java ramps up and it'll go up to 90-ish%, which right now Chrome is actually taking up a little bit more than it used to because of the recording. Up as much as it can to finish this task. So that's what the benefit is of all 3, having a thread or an executable, as well as your threads and executor service to manage it all for you. And I hope you guys like this, and I'll talk to you guys later.